Okay, sorry about that. All right, we're going to do the same thing with example 8. So if we have adjacent and hypotenuse, that is cosine. So we could say cosine of theta is my adjacent side 6 over my hypotenuse x. Okay, so how would you go about solving this? Well, we do the same thing we did up here. You would do inverse of 6 divided by x, and that would give me the angle measure. Okay, so this is, we just wrote this cosine statement as an inverse function using inverse notation. Okay, we would do the same thing for B. So here, your angle measure, this is your opposite side. We have an adjacent side, so that would be a tangent statement. So this would be tangent of theta is opposite x plus 3. I'm having difficulty writing today. Let's try it again. Okay, let's see. There we go. That's better. Tangent of theta is opposite over adjacent. And then rewriting that as an inverse trig function. So it would be inverse tangent x minus 3 over 12 equals theta. Okay, I haven't used the term arc sine, arc cosine really. You could rewrite either one of these using that arc sine notation. So this would also, or could also be written as arc cosine of 6 over x equals theta. Okay, so same statement. Okay, just different notation. Same thing here with tangent. We can go arc tangent of x minus 3 over 12 equals theta. Same thing, same statement, just different notation. Okay, example 9, find the exact value. Okay, so this is a composite function. We're going to start inside first. So we're going to be looking at this inverse cosine of 2/3. Okay, so inverse cosine is defined for quadrants 1 and 2, and the cosine is positive. So that means this angle is sitting in the first quadrant. Okay, cosine is adjacent over hypotenuse. Okay, now, if we go back up here, if we look at, go back to this statement right here. You have inverse cosine of 6 over x equals theta. Theta, this is an angle measure. Okay, so this is an angle measure. So this statement right here, this inverse cosine of 2/3, is describing theta. Okay, so what we're really looking for is tangent of theta using this triangle. Okay, so in order to do that, we're going to need Pythagorean theorem, and you're going to find the missing side, which is 5, because tangent is opposite over adjacent. So in order to find this statement, to complete this tangent of theta statement, you need that opposite side. So this becomes root 5 over 2. This is your answer. Okay, the tangent of that angle measure is root 5 over 2. All right, B, same thing. We're going to start inside. So inverse sine of negative 3/5. Well, arc sine or inverse sine is defined for quadrants 1 and 4. Since sine is negative, that means you are in quadrant 4. So same thing. Sine is opposite over hypotenuse. So opposite, this is the side that's -3. Hypotenuse is 5. Okay, now what we really want then is we want the cosine of that angle measure. So we want to know cosine of theta. Okay, well, again, we need that missing side. Okay, well, you can do Pythagorean theorem, or if you recognize this as a Pythagorean triple, it's 3, 4, 5. So now cosine of this angle measure would be adjacent 4 over hypotenuse 5. So there's your answer, 4/5. Okay, we have one last problem here. So the bottom of the swimming pool is slanted. So the water depth is 1.3 meters in the shallow end and 4 meters in the deep end. If the length of the pool is S and the angle of depression is theta, write theta as a function of S, and then B, find theta if S is 20 meters and S is 30 meters. Okay, so to start with, let's sketch and see what we have. All right, the bottom of a swimming pool is slanted, so the water depth is 1.3 meters in the shallow end. Okay, so right here, 1.3 meters. So here's our pool. Oh my goodness. And then here is the deep end. Okay, so at the deep end, okay, so there's my water. So water all the way down, top of the water, 4 meters down. Okay. Okay, if the length of the pool is S, so from here to here, this is S. Length of the pool is S, and the angle of depression is theta. So here's theta. Okay, so you're standing on the bottom of the shallow end, you're looking down, that's your angle of depression down to the bottom of the deep end. Okay, A, write theta as a function of S. Okay, well, here's theta. S is our adjacent side. Okay, so this would be adjacent. And then what other information do you have? Well, I don't know anything about the hypotenuse, so it's not that one. We're going to have to figure out something with the opposite. Okay, so this distance from here to here is 1.7 meters. Okay, so from the top of the water all the way down the bottom of the deep end is 4 meters deep. Okay, so if I subtract the 1.3 meters, then that deep end is 1.7 meters deeper than where the shallow end stops. Not 1.7, how about 2.7? Okay, and it's supposed to say 2.7. Here we go. Okay, 2.7 meters. So A, right? Theta is a function of time, or function of S. So I can go tangent of theta is opposite 2.7 over adjacent, which is S. Okay, now writing it as a function of S. Right now, this is written as a function of theta. Okay, tangent of theta. If I want it written as a function of S, you would rewrite this inverse tangent of 2.7 divided by S equals theta. Now it's a function of S. I am plugging in S, and then it will tell me what my angle measure is. Okay, so here's that statement for part A. Okay, part B. Solve this if S is 20 meters and then S is 30 meters. So we've got two options here. So I'm just going to take this inverse function that we have, And if S is 20 meters, if the length of the pool is 20 meters, I can plug that in, and that will give me an angle of depression of 7.69 degrees. Okay. Now, you could work in radians. This problem doesn't specify to work in degrees or radians, so it's your choice. I'm assuming probably most of you would prefer the degrees. And then the other one is if it's 30 meters long, what would the angle of depression have to be? And same thing, and it would be 5.14 degrees.